Hi everyone, so here's the answers to review 2.1 to 2.3 for your quiz on Tuesday. And you guys, we decided to make the quiz a little bit shorter than originally expected. So I'll kind of, as I go through, I'll tell you what you need to know. All right, so for question number 1, find the equation of a line that passes through the following points. Remember, I don't care if you write your answer in slope-intercept form or not. Okay, so look, to write the equation of a line, I always need a point, and then I need a slope. So because they gave me 2 points this time, I can pick whichever one I like better. I like 2, -3, but you can pick -4, 9 if you want to. And then to find the slope, because I have 2 points, to find the slope here, I could do y2 minus y1 all over x2 minus x1, which would be 9 minus -3 all over -4 minus 2. If you're wondering how I got that, you could go, this is x1, y1, x2, y2. Okay, so that ends up being 9 plus 3, which is 12, all over -4 minus 2, which is -6. So your slope is -2. Now, once you have your point and your slope, you plug it into something called point slope form, which is y minus y1 equals m times x minus x1. This is your x1. This is your y1. So when you plug it in, you get y minus -3 or plus 3 equals your slope is -2, x minus 2. All right, so there is your answer for number 1. I'll highlight it for you guys. All right, example 2. Find the equation of the line that passes through 3, 8 and is perpendicular to -2x plus 6y equals 9. So again, if I want to find the equation of a line, remember I don't care what form you put it into, you need a point and you need a slope. So this time I only have 1 point, so I kind of have no choice but to use 3, 8. Now, to find my slope, they didn't really give me one, but they gave me hints as how to find it. So they said it's perpendicular to -2x plus 6y equals 9. So let's find the slope of -2x plus 6y equals 9. So I'm going to add 2x to both sides. So it's going to give me 2x plus 9. And then I'm going to divide everything by 6. So that's going to give me y equals 2 over 6 reduces to 1/3 x, and 9 over 6 reduces to 3/2. So my slope is the number in front of the x, right? So my m is 1/3. But you guys, I don't want that slope. I want the slope perpendicular to it. Perpendicular, that means negative reciprocal. So you change the sign and you flip that. So my slope is actually going to be -3. And then plugging this, just like I did in the last problem, into slope-intercept form, point slope form, is y minus y1 equals m times x minus x1. Okay, so giving you hints on what's on your quiz, one of these questions is on your quiz. Okay, we just changed the numbers around a little bit, but number 1 or 2, I would know how to do both of these. So one of these is on your quiz, okay? All right, evaluating. So evaluating basically means replace x with what they give you. So here they said replace x with 2. So I'm going to make a little template here. So wherever I see x, I'm going to do the little parentheses. So something squared plus 1, something squared plus 1, something squared plus 1. And what do I put into that parenthesis? Well, it's whatever's in the parenthesis here. So stick in a 2, right? Here, I'm going to stick in a -4. Here, I'm going to stick in this x plus 2. Okay, so what do I end up getting here? 2 squared plus 4, that's 4. 2 squared plus 1, sorry, that's 4 plus 1, which is 5. Here I have 16 plus 1, which is 17. And here, this is a really good one. X plus 2 squared is really x plus 2 times x plus 2. So it's going to be x squared plus 4x plus 4. Remember, we're going to have to FOIL that out. That is really, really important that you know that. And then I have this little plus 1 in the end, so this should be x squared plus 4x plus, if I combine these two terms, you get a 5. All right, so there's those. Let me highlight those answers for you guys so you can see it. Okay. All right, number 4, evaluate. So here I'm still plugging into things, but the question is, do I plug it into here or do I plug it into here, right? So what gives me that answer is these little intervals. So here, if x is smaller than or equal to 1, -1, I'm going to plug it into here. If my x is bigger than -1, I'm going to plug it into here. So if I look at -2, -2 is smaller than or equal to -1. So I'm plugging it into the first interval. So it's going to be 2 times x plus 1, drop in that little -2. That's -4 plus 1, which is -3. Okay? F of -1. Well, -1, again, is less than or equal to -1. So again, I'm plugging it into 2x plus 1. So it's 2 parentheses plus 1. Put that little guy in there. So it's -2 plus 1, which is -1. And then 0. Well, this time we're going to be in this interval because 0 is bigger than -1, right? So I'm going to be plugging it into here. So it's parentheses squared plus 2. Plug in the 0. 0 squared is 0. 0 plus 2 is 2. Okay, so there's those 3 answers. Okay. All right, let's look at this one. Find the domain of the following functions. So remember, with domain, there's going to be 3 issues that we have with domain. Issue number 1, we went over this in class, is that denominators cannot equal 0. Issue number 2 is that if you have a square root, you have to take the inside of the square root, whatever's inside, and you have to make it greater than or equal to 0. Okay, and then the last issue is if you have a square root in the denominator. So if there's a square root in the denominator, you're going to take whatever's inside that square root and just make it greater than 0. The reason why it can't equal 0 is because denominators cannot equal 0. All right, so on this one, the first issue I have here is that I have a denominator. So I have this problem here. So let's set it up. 3x minus 9, that denominator cannot equal 0. And let's go ahead and solve that. So if I add 9 to both sides, I'm going to get 3x equals 9. If I divide by 3, I get x equals 3. Okay, so that's, and actually it's not x equals, what should it be? X does not equal 3, right? Because you don't want it to equal that number because you don't want it to equal 0. All right, for question B, on this one, I don't have a denominator, I don't have a square root. So it doesn't have any issues that we know of yet. So this is going to be, for now, all real numbers. Later on, we're going to run into different functions that have other issues, but for now, these are the only 3 issues you need to worry about. Okay, and what do we see for C? So in C, we see that we have a square root. It's not in the denominator, so we have this case right here. So I'm going to take the inside of that square root, the x squared plus 8x, and I'm going to make it greater than or equal to 0. Now remember, this is going to be a sine line graph because it is a quadratic. So I'm going to go ahead and take out an x to factor it. So I get x times x plus 8 is greater than or equal to 0. Setting each one equal to 0, so this little guy, x equals 0, would give me a 0 there. And this little guy, if I put in a -8 there, -8 plus 8 is going to give me a 0. And then because it's greater than or equal to, I'm going to go ahead and put solid circles on it. And then let's pick some numbers. So a number to the left of -8 may be like -10. If I plug a -10 into here, that's going to be negative. If I plug in a -10 into here, -10 plus 8 is also negative. So negative times a negative is a positive. Now you guys look, the exponent on this one is 1. The exponent on this one is 1 also. Because they are both odd, we can use our cool little trick, right? If it's odd, it's going to change signs. So if this was a plus, this is going to be a minus. This one's going to be a plus. And I want the ones that are greater than or equal to 0. So those are the positive ones, right? So I'm going to have all of this and then all of this. And when I write that, it's going to be negative infinity to -8, parenthesis, bracket, because it's a closed circle, union, bracket, because it's a closed circle, 0 to infinity. Okay? So that's that one. Let's see, if I do number 6, finding the difference quotient. Oh, by the way, you guys, there's one of these on your quiz. Okay, I'm not telling you which one, but just one. Okay, very similar to the one of these that we just did. All right, finding the difference quotient. So f of x plus h minus f of x all over h. So first, let's go ahead and do the same colors that we did in class. So we're going to have green, we're going to have blue, and then we're going to do green minus blue, right? So f of x plus h. This is the green part. That means to replace all these x's with an x plus h. So I'm going to get 2 times x plus h squared plus 3 times x plus h, and then minus 1. So this is going to be 2 times, if I multiply this out, I'm going to get x squared plus 2xh plus h squared, plus, if I distribute that, 3x plus 3h minus 1. If I distribute that, I'm going to get 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 1. So far, you guys, this is my whole green part, right? That is what corresponds to the f of x plus h. Now, what is f of x? Let's highlight that in blue. F of x is just 2x squared plus 3x minus 1. So putting all of this together, green minus blue. So here's green. 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 1. So that's green minus the blue. I'm going to put the blue in parentheses because it's more than one term. So minus 2x squared plus 3x minus 1. And then all over h. I'm going to do more colors on that. Look, here's your green. All right, there's the green minus the blue. See how it corresponds? Okay. Now, I need to distribute that negative through. So I'm going to get 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 1. Do I have more room? Oh my gosh, I don't. And if I distribute the negative, I'm going to get minus 2x squared minus 3x plus 1. All over h. And at this point, you guys, stuff should start canceling out. If it does not, you did something wrong, okay? So look, 2x squared cancels with negative 2x squared. 3x cancels with negative 3x, and negative 1 cancels with a 1. So what do I have left over now? I have 4xh plus 2h squared plus 3h, and then all over h. But if you look, every single one of these terms has an h. So I can get rid of 1h, 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 leaving me with 4x plus 2h plus 3. All right, so there is number 6. Okay, now finding zeros. You guys, that's just a fancy way of saying set this equal to 0 and solve. So 0 equals 5x squared plus 4x minus 1. So this is going to be a big star. So I need two numbers that multiply to give me negative 5 and now to give me 4. That's going to be 5 and negative 1. Then let's divide by the leading coefficient, which is a 5. This does not reduce, but this reduces to a big fat 1. So I'm going to get 0 equals x plus 1 times x minus 1/5. If I set both of these guys equal to 0, I'm going to get that x equals negative 1 and that x equals 1/5. So my two zeros, or the two places where this crosses the x-axis, is going to be negative 1 and 1/5. Okay? Doing the same thing with part B. If I make this equal to 0, 0 equals 8x plus 3 over 11 minus x. So one way that I could do this is just to multiply the top and bottom by 11 minus x. Right? 11 minus x times 0 is 0. This cancels out. So you guys, solving that equation, if I subtract 3 from both sides, I'm running out of room here, I'm sorry, I'm going to get negative 3 equals 8x. And then dividing both sides by 8, I'm going to get x equals negative 3 over 8. Okay, so again, the 0, or the place where this graph crosses the x-axis, is going to be at negative 3/8. Okay, consider the following function. Find the domain, the range, relative max, relative min, increasing, decreasing zeros. Okay, So let's look at it. The domain. The domain is the x value. So this one I'm going to be looking left and I'm going to be looking right. Okay. So for this, if I start here, how far left does this graph go? Some people think it stops here, but it doesn't really, because it kind of goes a little bit further, right? Now, you guys, because of this arrow and it's a little bit tilted, this thing is going to be going forever to the left. Even at like -10, this graph is going to be somewhere like all the way up here, right? It's going to look something like that. Does that kind of make sense? So it's going all the way to -infinity. And same thing on the right. This graph, even if it's like all the way out here, it's still going to have like an x value, like, well, not here, but maybe like all the way up here or something like that, where it keeps going and going and going and going and going. Does that make sense? So the domain here is going to be -infinity to +infinity. Okay. Now the range is my up and down movement. So let's look at that. So the range. So how far down does this go? Well, not here. It goes further than that. It looks like the lowest that it gets is -4, but the highest that it gets, because it keeps going up forever, is going to be +infinity. So this thing is going from -4 all the way to +infinity. The reason why I made it a bracket is because it actually hits -4. So the range is going to be -4 to +infinity. And make sure you put always the smaller number first, which means that it's going to go from like bottom to top. Okay, a relative maximum. This is, I'm just looking for a hill. Okay, and I see a little hill right here, right? Do you guys see the hill right there? So that point there is 2, 0. And a relative min, I'm looking for a valley. Okay, so the valleys here, I see a valley here, and I see a valley here. So I want this point and this point. So the point on the left looks like it's maybe like -1.5 and -4. And the valley here, that looks like it's like 4 or -1. Wait a minute, I've been putting it on the wrong one. I'm like, what? Hang on a second. And 4, -1, sorry. Okay, and then increasing. All right, I'm going to erase this horrific mess that I made here. Get rid of all this stuff. This is too confusing. Yikes. Oh, let me erase this too. Okay, so when I'm looking for increasing, clearly I can tell on this graph that from here to here, the graph is increasing, right? And also from here to here, it's also increasing. Basically, where are you walking up the hill? But you guys, I don't want to be looking at it from, oh, like what's the lowest point to the highest point. I want these all in terms of x, right? Okay, so if I want them in terms of x, I need to look at the x-axis. You guys, where I highlighted that blue, that's only this little interval, and then here, that blue is this interval here, right? So how would I write that in interval notation? This is actually increasing from -2 to 2, okay? So basically from here to here, the graph is increasing. So I'm going to do -2 to 2. And then also, it's increasing from 4 to, and it keeps going on forever, so 4 to infinity, right? So from here on, the thing is going to be increasing. So I can write 4 to infinity, okay? Now, where's it decreasing? Let's do that in a different color. So I'm going down the hill here. I'm going down the hill here, okay? And again, I want it in terms of x. So when did I start walking down the hill, okay? It was at actual -infinity. Because you guys, because of this arrow, like I started walking down the hill like, I don't know, 1,000,000 years ago, right? Because it has a forever, it's going forever up and to the left. So again, if I'm looking at the x-axis, it's going to be from here to here. So it's from -infinity, and then it stops decreasing at this -2. So this is going to be -infinity to -2. And then this little chunk, it's also right here, it's also going to be decreasing. So if that's from -2 to 4, +2 to 4, sorry. Okay, and then zeros. Okay, so zeros are where the graph crosses the x-axis. So here the graph crosses or touches the x-axis. It's at -2. So you can say at x equals -2. It touches the x-axis at 2. And also at 6, 6, 5. Okay? And then you guys, there's one question like that on your quiz. Okay, so if you're looking at the quiz wondering what should I really study, okay, you really should know all of it, but there's a question like 1 and 2. There's a question like number 5. And there's a question like number 8. And then I may, like, on the back of the quiz, give you like a little bonus question or something like that based on the other ones, like a little surprise. All right. But those are the only 3 that you really need to focus on. All right. I hope you have a great weekend. I'll see you on Tuesday.